Perfect. Hello, everyone. Welcome back to All Devs execution number 238. Today, I'll be the call coordinator again. Nix and I are by now co-leads, and so we will take turns, although not on a particularly regular pattern, just whatever makes sense at any given call. Um, Today, I put the agenda in chat. We have two main topics. One will be Glamsterdam DevNets, and the other one will be Hegota EAP proposals. On Glamsterdam, I think the main DevNet to talk about will be Glamsterdam DevNet 5. But before we get there, maybe I just want to briefly ask, is there anything still from the BAL DevNet 7 that we should discuss? Is there anything to bring up from there? Ben?
Not for Bell DevNet 7, but it'd be nice in the next um if we do another Bell DevNet to have the um target gas in it also, so there isn't a difference between the Amsterdam and the outside.
Makes sense. Yeah, I was going to, I think to me that was a topic forward looking for Glamsterdam DevNet 6. I think my understanding is that we are maybe trying to integrate the DevNets anyway, and that BAL DevNet 7 would maybe be the last BAL specific DevNet. But yeah, point taken for now. Let's get back to this once we discuss that question at the end. Okay, then let's for now go to Glamsterdam DevNet 5. Do we have a status on that DevNet?
Yeah, so Amsterdam Devon 4 basically died last week. So we ended up polishing up the CL spec, and hopefully now we will have a ready to go Amsterdam Devon 5. We just had Genesis about an hour ago, and we will be hitting the fork in 2 hours. We have the Dora page online here, and yeah, just keep an eye on it. We have 2 ELs and 4 CLs right now, and we're planning to onboard Deku as well right after the fork, or maybe tomorrow.
Sounds good. Thank you. Is there any action items or anything else for clients following along with the DevNet?
It would be also good if we had other EL clients take a look at the engine API changes, and then we can also onboard them as well.
Sounds good. Anything else regarding this just launched DevNet 5, some DevNet 5? Otherwise, I think we can briefly touch on, I think Barnabas also mentioned it in chat just now already, basically the DevNet plans going forward. My understanding is that maybe with Amsterdam DevNet 6, we would try to have that be a unified DevNet already. Is this, I'm not sure how much there's to discuss now on the call, maybe just so people are aware first of all, is this indeed, am I correct that this is the intention would be to have DevNet, Amsterdam DevNet 6 be the point at which we integrate the DevNets? Or is that still in flux?
Well, the point is that Amsterdam DevNet 5 is based on top of Paul DevNet 7, and any new ELEIPs that we would be wanting to push for, I would just want to push that into the Amsterdam track. Otherwise, we're going to have two very conflicting branches, and it might be causing some headache for the EL teams.
Okay, that makes sense. Sounds good. So basically, the idea would be that now, as of Amsterdam DevNet 5, that becomes the unified basically branch, and so we will not have a BAL DevNet 8.
At least that would be my suggestion. I know that some client teams would like to have Bold.NET 8 with some new EIPs.
Makes sense. And is that something to just flag now, or do we need to have that discussion now, or is that best suited for offline or on ACDT next week?
I think it would be good to agree on this now.
Okay, then yeah, let's see. Is there anyone who is opposed to that approach, who would like to keep the BAL DevNet separate for now? Right. So we would keep BAL DevNet 7 around. We would just not create a BAL DevNet 8, basically, would be the idea. Well, so far I've seen 100% pari in favor. Is there any client teams with any opinion either direction, or just otherwise we just can just follow the recommendation here? Okay, then I would say we just make that decision, and there will not be a separate BAL DevNet 8. At least that's the intention as of now. Of course, things can change, but the intention would be that BAL DevNet 7 is the last BAL specific DevNet, and everything further on the EL side will be on top of the main Amsterdam DevNets. Okay, awesome. Then anything else, any other topic, anything else DevNet related that we should discuss now before we move over to the Higota section?
Well, there's definitely some open EIP questions for DevNet 6 scope, such as what Tony just mentioned, the deterministic factory, deterministic deployer. There's an EIP for that, and whether we want to include it in the next one or not.
Wouldn't we include that with all the other EL changes?
Yeah, I mean, we should probably go through that list now and see which one we want in and which one we don't.
Yeah, sounds good. Do we have like a candidate list we could take a look at? And what's the timing for sorry, Amsterdam DevNet 6? Like when would we expect to launch that? Assuming BAL DevNet 5, of course, is decently stable.
It's all up to the client on the decisions which EIPs we're gonna include and when it will be ready.
Okay, makes sense. Yeah. Then
Preferably in 2 weeks, not more than that.
makes sense. Yeah, I'm a little because of the integration of the DevNets and overall, I'm a little out of the loop on which specific ERPs need decisions for DevNet 6.
There's
And
I just linked it, the execution specs issue, 2915. And then there's the list that Spencer put together.
So I think there's two issues. One, I don't. We should really discuss at this stage. I think they're all quite small. What we want to hold back rather than what we want to include. But the other caveat is we need benchmarking numbers for some of the EIPs to know what their finalized numbers are, or at least semi-finalized numbers for the DevNet. So it's not just implementation time, but for instance, like 8038 and 2780. They need finalized numbers from the benchmarking.
Do we need the finalized numbers, or could we just have a good enough estimate to
Yeah,
run the
we
next
can.
DevNet and then have the finalized numbers for like DevNet 7?
We just need some. We don't need finalize. We just need some numbers.
Tony, do you have your hand up for that topic?
Yeah, so assuming we have the finalized numbers for the repricing EAPs, my feeling is there is only the deterministic factory left, right? There is only 7997. Am I forgetting any EAP now that we have also CFI'd?
Well, I mean, all the ones. So the ones changing all the numbers are also not in. So it's not there, just the factory. I assume we include everything that we've.
No, I mean,
CFI'd.
ignoring the repricing EAPs now, because for them, I just assume we get to the final numbers and then we SFI them. More like which other actual features that is not just repricing is still open.
The self-destruct one?
Right. It feels it's those two, the self-destruct and the the deterministic factory.
There is also 2780 reduce intrinsic transaction gas.
Right, but I count it as repricing. Basically, 8038 and 2780, those are waiting for the final numbers, and as soon as we get the final numbers, we can basically SFI them. If everything looks good, of course. And for the others, it's still like I would call them. I mean, the self-destruct is more a security thing, but the factory is a feature. Both are very small. So I would just lean towards including them in DevNet 6.
And also all the EIP updates.
Yeah, it looks to me like in terms of new EIPs, we have two repricing EIPs, two feature EIPs, the self-destruct and the deterministic factory pre-deploy one, and two out-of-protocol EIPs, right? The sparse blob pool. Oh, I forgot. Maybe I'm wrong. I'm not 100% sure about this. My thinking was it was networking only, and the revert creation for non-empty storage, which, if I remember correctly, is also just a pure, I don't know, like formal decision only thing. Is that right? Is it basically like two repricing, two features, and two out of protocol ones? It's basically okay. That's so on the repricing we already flagged. The main decisions are or the main questions are around the readiness of the benchmarking. On the two features, which basically is anyone opposed against including both of them. So like that's the self-destruct one and the deterministic factory pre-deploy. Is anyone opposed to having both of those in DevNet 6? Okay, then it seems like they can go ahead in DevNet 6. And then regarding the other two, like the 8070, the sparse blob pool, and 7610, the revert creation for non-empty storage, is there any considerations about they're listed for inclusion in the DevNet? Yeah, any considerations around those two, Camille?
Yes, around the sparse blob pool. So it's an EL change. We have Geth, which is close to be ready to ship this feature. Also, Nethermind and Ethrex are actually working on that. But the problem is that we do not have CL support to kind of enable sparse blob pools in the DevNet. So when it's ready on CL side as well, I think, yeah, we can get prepared and schedule that for the upcoming DevNets.
I would actually push this feature into possibly Hagota, as we still lack the optional blobs on the CL side. And that is a huge lift. There's a lots of implementation that needs to be done, and only Lighthouse and Prism has done that. But it's all optional, so we can treat it as an optional EIP. So once the EL and CL both supports it, then we're just gonna enable it. We don't need to have a fork for this.
Sounds good. So there isn't really any DevNet decision to be made here for this EIP.
On my view, it would be great to, once we have CL support, to maybe schedule that first for the blob devnets. Yeah, once it's stable there, we can consider also for Amsterdam. I don't know, it's not like a consensus change. Yeah, it's just if nodes, well, the clients, they signal that it's ready, we can start considering scheduling that. Yeah, it's a question like whether for Amsterdam devnet or for Hagota. Ideally for Amsterdam, but yeah, depends on the readiness.
Okay, makes sense. So then, yeah. So in terms of actual inclusion decision for DevNet 6, it's kind of then out of scope because it's optional anyway. So then we have the two kind of feature EAPs where it seems like everyone agreed we would want to include them. So where does that leave us with the two repricing EAPs? Did we say we will definitely have kind of preliminary numbers and would want to include them on that basis, or is it still an open decision question? Okay, Tony is saying let's just basically not make the decision on the repricing ones today, but basically just say they are meant to go in as soon as the numbers are there. So if the numbers come in time to make it into DevNet 6, they go into DevNet 6. If not, then basically they wait. Barnabas?
Are these literally a one-line change for most ELs to change these values? And because if they are like one-line change, maybe we already have a good enough estimate of what values would make sense, use those so that we change the repricing values to that and then do benchmarking on them as well. So that we can actually include the EIPs in the new DevNet and do the actual change and repricing. Yeah, I'm not sure if it's going to be the correct final value, but at least the EIPs will be implemented and the change will take place. And yeah, Pari mentioned that it would be nice to see what tooling breaks. As we saw with AD37, there was a ton. So I would actually try to push for all the EIP changes in DevNet 6, if possible.
Okay. I mean, it seems reasonable to me to basically say like they don't even have to be like high quality kind of penciled in values. Like as long as they basically just give us the testing surface to test having those changes, and then the real numbers can come later. And as long as they're roughly like pointing in the right direction, the numbers. Yeah, I mean, I'm not in the loop enough to say whether that's possible. It seems like that should be possible, but maybe we can for now just have that as the intention for DevNet 6 and then check in with the benchmarking effort and maybe on next week's ACDT, if that makes sense. Basically, have just confirm that. Okay, I see some thumbs up. So, but yeah, so then let's say the intention is to have some preliminary version of 8038 and 2780 as well in Amsterdam DevNet 6. Okay, and then is there any decisions we need to make on the EAP updates? I see there's three EAPs with updates listed as well. Anywhere there's the decision to be made, or would we just include all the updates in the DevNet?
Sorry, what did we decide on the self-destruct one? 8246?
I had asked, yeah, I'd asked whether 8246 and 7997, whether on those two anyone was opposed to including them, and there was no one. So I by default would just include them, but if there was, if I maybe just didn't mention it clearly enough. So is there anyone who was opposed to including 8246, the self-destruct burn removal, or 7997, the deterministic factor pre-deploy? Is there anyone opposed to including both of those in Amsterdam DevNet 6? Okay, then it does seem like we just go ahead and include them. So that means we include four new EAPs, the two repricing EAPs, 8038 and 2780, and then the two feature EAPs, 8246 and 7997. And then my understanding was that the other two listed there do not require a definite decision. Okay. So then if that's my understanding, then the question again, like there is also for the EAPs that we already had in the prior DevNets, 3 EAPs have changes. My default assumption would be that all changes will just be in DevNet 6, but if there's any change that maybe has some reason for why that might not be the right decision, I don't have the context on this, so just asking. Okay, then I assume we'll also have all the changes listed there, the EAP changes as well, included in the DevNet. And yeah, Barnabas, the last one that I was unsure about from the ones that you listed is 7610, because again, my understanding is that doesn't actually change any behavior on mainnet. It's more a formal change, if I remember the discussion correctly that we had in the past. So I'm not quite sure if that needs a formal inclusion decision.
Yeah, I can maybe chime in on this one. I don't see Gary on the call from Gav, but he could shine some more light on this. I would not want to move this ERP to any other position yet, but you are right. This is not it's currently a no op. It's more a decision like, should we include this in the spec? But I don't want to have that discussion now because I want Gary on the call for that.
Sounds good. So then I don't see a need to include this in specifically in Amsterdam DevNet 6. I think we can just postpone that. Okay, sounds good. Then it does seem, but otherwise, Barnabas, your comment looks correct to me. Yes, then I think that's all regarding planning for Amsterdam DevNet 6. Any last DevNet related topic anyone wanted to bring up before we move to Hikota? Okay, then let's go to Hikota. We have 7 different EAPs across 4 different people that wanted to bring them up. So let's just go through them one by one. Tony, you were first. You had 2 EAPs you wanted to bring up.
Yes, let me quickly try to share my screen. Let's see if that works. Okay, I guess it doesn't work, right? You just see a black screen.
I
Oh,
only
does it
see a
work?
black screen. No, only black.
That's interesting. Can you
we
share
see your
my
mouse.
screen and
Yeah, the mouse is there.
you? Interesting. Okay.
Do we have anyone else
yes,
who
just
could
like-
just spontaneously share the screen?
And click my link. Yes, I posted the link in the chat.
Shall I share my screen?
I think
Josh
was
is going.
Yeah.
sorry.
Thank you very much, Josh.
Awesome. Thank you very much, Josh. I will just tell you when to switch to the next slide. So yeah, those are two repricing EAPs for Hagota. Both are targeting to make the worst case block size smaller. And just to give you a sense of where we are with Amsterdam. So with 200 million gas, we will get to like 4.5 megabyte big blocks. This sounds quite a lot, but for example, we were quite close to that already pre-Pectra, for example. And the nice thing is with Amsterdam, we get much more time for propagation thanks to ePBS. So an increasing block size is not that scary anymore as it was before. But still, we need to somehow keep the worst case block size in check, such that we don't end up in a situation where big blocks basically don't propagate anymore over the network. And those two EIPs, basically 8131 and 8279, they get us to a point where we decrease the worst case block size by 32%. And the nice thing is we get to a worst case block size formula that is basically block gas limit divided by 64. And 64 is the gas per byte cost that we introduce with Amsterdam. Great, let's go to the next slide. So what is the problem today? Today we have the floor call data pricing or the floor data pricing. And this means with Amsterdam, you can use 75% of the gas available for execution. And for example, do a lot of S loads. And you use 25% of the call data for data to increase the block size through call data. And those 25% is already giving you the worst case block size because you're not hitting the floor in this scenario. You're still paying the 16 gas per byte instead of the 64. And this allows you to basically shuffle execution on the other end. And this execution can then in the end contribute to the block becoming even bigger. And the block level access is just one of those things that you execute something and suddenly the block becomes bigger. But there are other components in the block we have that have a similar phenomenon. For example, 7702 offs and also blob hashes. Both contribute to the block size and both are not priced for their data at all. In Amsterdam, we already price access lists. So this is already quite nice because now the block size decreases already. And the first EAP I had there, 8131, would basically also do the same for 7702 offs and also for blob hashes. And the second EAP would then apply the same to the block level access list, which is a little bit more involved, but I will get to that in 2 slides. Let's move on. Perfect. So this is very simple. What we do with 8131 is essentially the last 2 lines here. We also account for the authorizations and we also account for the blob version hashes. And this is all the data that a user has access to. And by doing the CAP, we basically have all the data priced with the same price, at least at the floor. So here you can see with the 64, for example. And this means we then end up with call data, blob version hashes, only those few bytes, authorizations, and as well as the access list, all priced with the same cost. Let's move on to the second EAP, which prices the BAL. And this is a little bit more complicated because, of course, in order to know that something will increase the block size, you have to execute. And this in turn means you have to start. So the previous EAP was only like intrinsic gas, very simple. But this one is more complex because you only discover what is about to be put onto the block level access list during execution. So let's start from the beginning here. We know what triggers something to be put into the BAL. And this is, for example, a call to a cold address or S loading a cold storage slot. Importantly, it's always cold, right? Because as soon as we do a warm S load, we know it's already in the BAL. And the same applies to store, create, self-destruct, and so on. All those opcodes, we know them and how much they put into the ball. For example, a call opcode puts a 20-byte address into the ball, whereas, for example, a create deploy puts the length of the code into the ball. And what we would now need to do is, during execution, we would first determine the floor cost just using the intrinsic gas. This is like we do it today. And then during execution, we would introduce a new out of gas failure. And this would be raised if the floor gas used would go above the transaction gas used. So the interesting part here is each opcode, for example, for an S load, you would now also pay for 20 bytes of data cost, at least at the floor. So this is important. The normal cost of that S load, as it is 2,100 as of today, wouldn't change. It would only change if you have a transaction that hits the floor, the data floor, just like we have it today. But now this S load also contributes 20 bytes to the floor cost. And by doing so, we get to this very nice picture where you end up with all the data in the block being priced the same, at least on the worst case size. And for average transaction, this also means we don't really have to touch them. So for example, we could even not apply any data pricing on a regular S load at all, only for those transactions that actually hit the floor. So this strikes a quite nice balance between reducing the worst case block size, also accounting for BAL, and at the same time not impacting the majority of users. And yeah, we can go to the final slide I have there. We can even skip that one. I already mentioned that the formula is now block gas limit divided by 64, which is very nice because today it's very complicated to actually calculate the worst case block size. And here we can see the impact of those two EAPs combined. So the first one that deals with the intrinsic gas would increase the cost. So the gas used for 3.29% of the transactions. But importantly, most of them are already paying the floor cost today because we have 7623, we will do 7976. So most of them already pay the floor cost. For them, it's just a constant increase. And of course, a few more users that might suddenly pay the floor cost because they use blobs. For example, you can see here that most 4844 transactions, they would be affected, but only like negligible. And also 7702 authorization would be affected because they actually come with quite a lot of data that is not priced in. So yeah, the TLDR is quite a massive 40% block size reduction, and only a few more percentages are affected. And in the end, it's like cleaning up everything around data pricing. And one final thing, those two EAPs don't even need to determine what the final price, the gas cost for a byte of data is that we want to have. It's more, they set up the stage to have everything priced fairly. Basically, every byte of data that a user puts into a block is priced fairly across everything we have. And the same applies to the block level access list. Awesome, that's all I have. Thank you.
Awesome. Thank you very much, Tony. And thank you, Josh. Ben, you have a comment?
Yeah, so at the moment we've put in the block size cap, which is like a sort of an emergency backstop, as it were. And so is the goal of this to bring back in the economics in terms of enforcing that cap rather than hitting the cap and it just distorting the market for gas.
Yeah, it's an interesting one because today we have the cap at 8 megabytes and then 2 megabytes for the CL, so 10 megabytes. And today we are far away from hitting that cap at 60 million. Like the worst case block size I just mentioned was 1.5 megabyte compressed, of course. And we are quite far away from hitting that. And of course, uncompressed, we get closer to that. And I would argue we should try to stay away from hitting that cap because it just makes building less efficient. Fortunately, with the transaction gas limit, things became nicer. But still, I would just keep this 8 MB limit and potentially just try to stay away from hitting it and keep it as a security mechanism.
Sounds good. Any other comments now? Questions? Yeah, okay. Thank you, Tony. Next up, we have Greg, who wanted to also talk about two EIPs, 7979 and 8173. Greg?
Good morning. Can people hear me?
Yes, we can hear you.
Okay. I'm fighting a bit of a cough, so I hope I'm audible. One of the IPs is just informational, because the motivation section on 7979 was just way too big. I've made one substantial change to 7979 that's worth discussing. Which is rather than have the client need to implement the validation algorithm, I'm thinking to do what I noticed the researchers are starting to do, uh, which is to move that algorithm on chain so that a client can simply take the output of the init code and run it through the algorithm that's already on chain. So a client does not need to write that validation code. There's a canonical version on chain that people can use. And the only reason to write your own is if for some reason calling that is harder, or you've got performance issues or something like that. But in general, clients don't need to do that. So the implementation can become very simple. So that's the main substantial change that I wanted to point out, to see if that could cause problems I'm not aware of, because it's been a long time since I worked on client internals.
Yeah, I'm not sure if we have had clients already that have already had time to look into this, or now hearing it live have an immediate opinion on it.
Does everyone at least understand what I'm proposing to do? And
It seemed to make sense to me.
okay.
But yeah, I'm not sure. Maybe there are questions. I could imagine people maybe just need time to have a look.
Yeah. And it's actually could be a pretty general mechanism, um, that pretty much anyone could take a header, drop in the address of validation code, and the client could run it and not really care at all what the validation algorithm is, which means that compiler teams and static analysis teams could decide on a particular algorithm they want to use, and they no longer have to bother the core devs about it at all. And that makes sense to me because in industry, object formats aren't really the problem of the compiler. Yeah, those are pretty much up to the linker. And the other issue, which is too much to discuss right now, but I wanted to make sure it's on the table now rather than the day before we ship, like last time, which is there are no code sections here. Subroutines are not a contiguous section of code. The validation starts at the beginning of the program. It traces the entire control flow of the program, and it simply doesn't have any reason to care how the bytes are laid out syntactically. And people seem to object to that strongly. And EOF worked hard to maintain separate sections. The problem being that certain optimizations really required the possibility to jump out of one section, one function into another. So they had to introduce special purpose opcodes for that. And I'd much prefer that compilers can simply do those optimizations without the instruction set just getting in their way. And so that's something that's there and will need to be discussed. And again, if it's truly a showstopper for someone, I want to stop the show now rather than after people have done a lot of work and the community has raised a lot of expectations that this is coming. So I just wanted to point that out. We can discuss it some now, or it can just be there. And please bring it up on the magicians if it's an issue you care about, because jumping in and out of subroutines was a huge issue. And at the time, I was not able to explain why for machine code that was just not an issue the way it is for higher level languages. So those are the two things that I wanted to point out in the specification that are going to be open issues and issues that could resurface very late in the process and possibly cause a huge storm on Twitter. And for some reason, we seem to care about huge storms on Twitter, or shitter, as I call it these days. So that's that.
Sounds good. I think you also said in the agenda comment that you think it might make sense to have a breakout call scheduled to follow up, because obviously like some of the implications here are like a bit nuanced and would be good for people to have time to look into it. Is that A, I assume that's still your intention, and then B, the question to me in my mind is mostly just around timing, when to plan something like this so that people are maybe not too distracted with Amsterdam work. But yeah, I'd be curious about your thoughts on having a breakout
Yeah,
call.
definitely we want to do that. Josh has been helping me with that. Um, it seemed like the schedule was running a little slower than I thought. And personally, it got slowed down because we had a death in the family. Um, so yeah, I'd like to do that soon. I'm not clear on when it has to happen. Um, so far as leaving enough time after it for everything we have to do. Yeah.
Sounds good. Yeah, and my condolences with the family
It's okay.
situation.
It been
Um,
coming for a long time.
yeah. Regarding the breakout call, I think yes, then it's good if you're already in touch. I personally would maybe recommend being intentional with the timing. I think we haven't yet even decided on a date for the end of the proposal windows of new APs for Hikota, and then once that is done, there will be the time period for decision making. Obviously, you don't want to be too late in that window, because then there's not enough time to then iterate on the results and have that be part of the decision-making basis. But if it's too early, also people might be distracted. So finding the timing, but I think Josh and the protocol support team can help you kind of figure out what the optimal timing there is.
Okay.
Okay.
Okay. At my end, I think the spec is pretty close to completely solid. The main issue is just convincing the editors to merge it. It can take them a month to merge even the smallest change. Um, so I'm down to pointing people at blobs, but hopefully at some point there'll be a solid draft that'll be easier to review and easier for the community to review. So that'll be one blocker on the breakout is to get a draft actually merged and published. Yeah. So I don't see any big problem on doing just picking an appropriate time, place. Okay, thanks very much. And if these are things you care about, please do think about them and bring them up on the magician's list or bring them up with me personally. Um, oh, my co-author on the validation algorithm and the ZK implementation passed late last year. So I no longer have anyone to help me on that. So that's also something that's going to need review on the lists, or even need a co-author if somebody is really motivated. This is one reason I've been pushing on it, because I'm losing co-authors.
Yeah, well, my condolences there as well. Then hopefully we can reverse that trend and have your number of co-authors go back up again. Okay, but then I think we have good next steps with you kind of merging that that draft, and then us finding a good date for breakout.
Okay.
Okay.
Thank you very much.
Thank you. And then we can move to the next one. That's a single EIP by Mohammed. That's EIP 8222. Are you on the call?
Yes. Hello. It's going to be a very quick sharing. Our intention is mostly to just gather more feedback and like just sanity check the core ideas. The EIP is far from, being ready to merge. There is a magician topic for it, so you can chime in there. But I'll tell you more about it in a bit, and I would love to hear your feedbacks. Give me a second. I don't know how to do this, but sorry, I have to leave and join with somebody else. Please do it for me so I don't have to do that. Pierre, could you please open the docs, or like if somebody else?
Yeah, sure. I can.
Thank you. Awesome.
Okay,
Thank you,
perfect.
Pierre.
We can see the screen.
Yes. So this is an AIP co-authored by Pierre and I. It's called Linux staking. The motivation is Ethereum doesn't offer any privacy at base layer, so we want to solve that. That's a key motivation. There are application layer privacy tools, but none of them offer meaningful plausible deniability, meaning that when you interact with them, it's obvious you're seeking privacy. they're not post-quantum, they're small privacy pools and often extractive, opinionated, and so on and so forth. Next slide, please. So yeah, and also validators are backbone of Ethereum, but there is no privacy protection for them, meaning that when they move funds from execution layer to the consensus layer and like deposit into beacon chain, they reveal that, okay, I'm going to run this validator identity, and you can link it with my on-chain identity, and maybe potentially extract more information about me. And it's important to note that there is like network level anonymity, and it's a mature, well-studied topic. Like you use mixed nets and onion routing and so on and so forth. But for the problem of linking your on-chain identity to the consensus, node, there isn't much discussions. And the side effect, or potentially the cherry on the top, is that users who want privacy but don't want to run validators may benefit from this, introduction of privacy for validators. Next slide, please. And in a nutshell, that's like the big thing is we want to introduce a base layer privacy pool and route the staking flows through it so that this privacy pool is big from day one and could offer plausible deniability because like using it looks like you're using the staking flow. You're going to operate a node and so on. Just a simple diagram. Today, when you deposit into the beacon deposit contract, you reveal that, okay, this is my ETH, this is my validator key, and this is where I'm going to withdraw to. So these are all linked. The idea is you deposit in a new version of the beacon deposit contract that doesn't take all this information from you directly, but take them as a hiding commitment, as the hash. And then you can reveal the content later and claim it. And you could use frame transactions, relayers, and so on and so forth to do it without doing it directly from your main account or the same account that made the deposit. So we call this a two-phase deposit. And so far, what we described in this slide doesn't need any changes in the consensus layer. Next, yes, thank you. So what this achieves is it breaks the link between the validator identity on the depositing side and the withdrawal side, but it doesn't break the link between the validator, public key, validator identity in consensus layer, and withdrawal credential. So the address that gets the funds, ultimately, the withdrawal credential doesn't have like a broken link. So we call this like one-sided plausible deniability, and I explain a bit more why that's the case. I see a question, but I respond after I finish. There is a few more slides. The next part of the idea is that applying the same thinking to the withdrawals. Basically, we could introduce a new withdrawal credential type, say type 3 or type 4. I see there is a type 3 already in some active EIPs, so that doesn't matter. Don't confuse them. So there is a new withdrawal credential type that's basically a commitment to a recipient address rather than an address. So if you choose that type of withdrawal credential, instead of receiving the funds when you withdraw or when a withdrawal happens for you directly, you receive a commitment in a contract that you can then go and claim by revealing the address inside the commitment you made. So if you go to the next slide, Pierre, I can deliver the punchline. So the punchline is you could make pending deposit in a private beacon deposit contract, and without going through all the validator queue, withdrawal queue, deposit queue, stuff like that, you could directly nullify this and take it to the withdrawal pool. But the funds that come out of the withdrawal pool look like or are mixed with the funds that been withdrawn from the staking consensus layer staking. So they offer you a lot of privacy because there's a ton of activity. And we already have a POC using LeanVM for the circuits. So if you're, I'm sure all of you are familiar, but the LeanVM is basically an effort to create a post-quantum VM that could be across, could be used across Ethereum, like including verifying signatures in consensus layer and so on and so forth, but broadly for other things as well. So we implemented these things in LeanVM, and although LeanVM is experimental and not very optimized and so on and so forth, it runs very fast and works great. And there are plans to implement this in REST. Had tips to Anton and others in the privacy transaction, private transaction engineering team in EF. And that's it. So I already see one question. So the question is, why do we do this at the beacon contract level rather than any application thing? So I guess one big thing is you get plausible deniability in this design, or at least we claim that you get plausible deniability by forcing a lot of legitimate protocol flows into the same, pool, right? So if we want to achieve that with the application level thing, we need to force, stakers to go there, which sounds not very achievable. Like I understand we could implement this protocol primitive as a contract or as an application, and then make it a protocol rule that everybody should pass through that, the withdrawals and deposits should pass through that.
What I mean is, why can't you just use any privacy pool
Yeah.
at all? Just use
Yeah.
any privacy pool that people are using for anything else, like Tornado Cash
I
or
see your
whatever
point.
it is.
I see your point. Yeah. Then you don't get this plausible deniability. Like, say I use Tornado Cash today, and my address is immediately flagged as somebody who's seeking privacy. And the reason is legitimate flows, or quote unquote legitimate flows, don't do that usually. But if it's a protocol rule that everybody has to do that, then I could just simply claim I'm participating in a quote unquote legitimate protocol activity. I'm not actively seeking privacy. So that's the key idea. As I said, like the EIP in a nutshell is to introduce a privacy pool or pick a privacy pool and force the staking flows to go through that. And the staking flows are big, obviously, and that gives you plausible deniability, so on and so forth. I understand it's a sensitive topic, and the reason we are bringing this up here is to just gather this kind of feedback. So yeah, please let me know. Go ahead.
Portus, do you have your hand up again or
Yeah,
still?
so if I understand correctly, an application of this could be, if we phrase the EIP in a completely different setting, would be, we want to enshrine a privacy pool that is guaranteed to have a lot of traffic. Therefore, let's have a privacy pool in which every staker is forced to send money there, so that at least we know that this privacy pool is going to have a lot of liquidity. So if in that sense, it would just force to have a privacy pool on L1 that is forced to have a lot of liquidity. If that's the EIP, at least it would have some sense to me.
That's the intention, yes.
Tony?
Yeah, to me, I'm not sure if like the users of privacies and the people staking, if this is like a set that harmonizes very well. Because, for example, you have like 32 ETH requirements for staking, which is like you won't provide privacy to a lot of users there. And also, like staking has no predictable turn. It's not like your anonymity set, which is rather big, is actually that helpful. Yeah, I'm not sure about this EIP. To me, it feels like simply withdrawing and then using a privacy protocol would give you very similar guarantees about privacy, and we won't need to enshrine anything.
I can quickly respond to the point Tony has. So I agree that the churn is not predictable, or like fluctuates a lot, but the churn is indeed a lot higher than the churn you get on the typical privacy pools, at least 10x on the worst days, and often like 100x more. And again, the reason it's different from like using a privacy pool at application layer is like this notion of the power of defaults, or like what's the legitimate action. Like that, if you ignore the plausible deniability part, this doesn't make any sense. You are all right. But the idea is achieve something like the wormhole EIP that like can't be achieved without compromising on bit security, but we want to achieve that with like without compromising on bit security. So instead of picking like transferring funds to a random address, which looks like a legitimate action, we picked like another legitimate protocol primitive, which could be like a bad idea, but that's the intention.
Peter?
Yes, you said that a core part of the IP was having to compel people who are staking to go for the privacy pool. I don't understand how you can do that because currently there are a bunch of existing mechanisms, and we can't disable those existing mechanisms because we'll break everything. We'll break all of the existing like staking pools. And if we keep the mechanism, there's nothing to stop users from just using the old ways of doing it and no one putting anything into this pool. So how do we compel people to use the pool without also breaking all current staking infrastructure?
Very good point. Indeed, like you need to, at some point at least, disable the old flow to make sure that this goal is achieved.
You cannot.
Like never.
Ideally, never. Yeah. I mean, it's like disabling an opcode. Like we've been trying to get rid of self-destruct for what, 6 years now, and there's still like one random guy that's using it, and that's why it still hasn't been removed. So like removing a functionality is not, it's not easy.
I see.
I think this is very easy. We can just force every validator to be 0.04, and then the contract is not disabled for 0.04 validators. So it should be easy to make this kind of changes in particular. It should not affect existing validators, but it would affect every new coming validator. But again, this should be analyzed in the form of we want to enshrine a pool and then force every validator to deposit in that pool, which seems kind of crazy at this stage on L1.
Right. Yeah, I mean, it seems to me like there's a lot of questions, a lot of skepticism around this for now, but I think it's good to have the presentation, have this as a proposal on the table. One question that I saw was the clarification of, is this something that you are considering proposing and pushing for Hegota, the Hegota fork in particular, or was this more just a initial bringing up the topic initially to basically have that conversation longer term?
Yeah, I mean, it's very unlikely that this could be part of Hegota. Sorry if that was a mandatory like requirement for sharing, but the reason it's unlikely is LinVM or an alternative proof system is required to be mature and well audited, and it's very unlikely that could be the case for Hegota. And like we require to enshrine a proof system for this for sure.
Makes sense. Yeah, no, I just wanted to double check. I think it was purely on me. I miscategorized it, but that's fine. There's no strict requirement to only propose a good EAPs, but I think it's still good for everyone to have that clarified. Yeah, then I think for now it's probably we've kind of given this general overview. I'm sure there will be continued lively discussion on this. But for the call, it's probably good to end the discussion on this EIP here. Thank you for the presentation, and then we'll move on to the last two EIPs that Matt wanted to bring up, Lightkind wanted to bring up, EIP 7851 and 8151. Are you on the call?
Yep. Thanks, Sanskar. Yeah, so I'm presenting a couple EIPs. I've been working a little bit with the authors, Colin and Nico, on. They kind of like fit into this broader suite of account abstraction and completing the migration of EOAs to smart accounts. So today with 7702, we kind of give EOAs the ability to act like they're a smart account. But we don't really give them the ability to disable their EOA key. And so this combination of 7851 and 8151 sort of allow users to fully deprecate their EOA key and focus on whatever security they enshrine in their smart account. So I can quickly say what both of these EAPs do. 7851 is the code controlled EOA delegation. Basically, the idea here is that we allow the user account to make their 7702 delegation permanent. So they do this via an opcode. So once you have delegated to a 7702 account and you're using the account, you can then call this opcode with the target of the target delegation that you want to make a permanent for your account, and it will change your delegation so that it's not a 7702 delegation, which is EF01, and it becomes an EF02 delegation. And so now we can treat this differently. We can not allow it to originate transactions, for instance. We can also disallow future delegation changes via 7702 at that point. So once that opcode is called, it becomes a permanent fixture of the accounts code. So that gives us the ability to disable 7702 and transaction origination for the account. That's a lot of the use of the EOA key still. Then we still have the problem of how to deal with EC recover, and that's what EIP 8151 handles. It's the deactivation aware update for EC recover. So now when the user or when the protocol does an EC recover, what it will do is it will take the recovered address and it will just check the code for that address. And it will determine if that code is a 7851 permanent delegation. And if it's a permanent delegation, then it will disallow, a positive successful return of EC recover, which in turn disallows the user from using their EOA key or some other actor to use that EOA key to take funds from the account via things like permit2, any kind of like on-chain mechanism that relies only on EC recover signatures. So that's kind of the idea with these two contracts, or sorry, these two EAPs. Ultimately, we just want to make it so that there is a clear path for users to delegate, permanently delegate and totally disable their key. To me, it makes sense to start looking at this for Hagota. Some users are wanting to, begin migrating to post-quantum accounts, whatever that, exact scheme ends up being. And so the sooner that we can start supporting this, the sooner that applications can begin building the tooling and the wallets can begin supporting this type of migration. Ben?
Yeah, I have rather than moving from a 7702 to a EF01, have you considered using a set code from opcode, which would be more general? because so rather than moving to another proxy, you just change your code, and then naturally the transaction pool rejects transactions initiating from a source that has code that just fits in. And then you could use it for something like 8058, which is duplicating, like if you're deploying an LP where you're constantly doing create two, you could also use it for that.
Yeah, I mean, I'm personally supportive of a more general use of the delegation. I think we tried to make it as small scoped as possible, focus on this problem. But if people are open to a more generally scoped set code type of operation, then I think that's honestly great as well.
Yeah, it would still need an address. So rather than a hash code hash, it would still need an address so that you're copying from something deployed.
Yeah, I mean that's a great outcome as well to me.
And then if we did go that way, for the 8151, that could be just changed to if there's regular code, disallow the easy recover. So it would affect all contracts also.
Right. Yeah. Yep, that's good feedback. Is anyone initially against a more generalized solution for letting, kind of basically building an in-protocol proxy system with set code? Amin?
Yeah, I just wanted to say that we can't really do what Ben suggested about EC recover, where it just checks if there is code, because some account might have a delegation, but it's the
regular code.
It's the yeah.
Yeah, so it would have it would say if you're a 7702, you can EC recover works. But if you're a regular code, not a delegation.
Yeah, but that's I don't think that's related to the topic though. Like that's a different issue now, isn't it?
That's the second DIP.
No, I know the second EIP is about disabling EOA and EC recover after you do that the opcode that disables the EOA. But adding another functionality to it doesn't seem to be the right thing to do. I don't know, not sure.
Okay, but I'm saying you change it. So at the moment, transactions are rejected if they come from an address that has code. And it would just change the EC recover to be rejected also from addresses that have code. So it's like a simpler, it would be a simpler version.
Yeah, but it has to be code that is not a normal 7702 delegation with 0, 1.
Yeah, i.e. ones that would be accepted by the transaction pool. So yeah, regular code. But I'm just saying we could make the upgrade path 7702 delegation to regular code. And then that would automatically deactivate the EOA.
Also, Matt, I'm thinking about the potential criticism of the opcode, that it might be abused by phishing attempts. Shall we only enable sit code opcode for delegated accounts that have already migrated to disabling the EOA, so that the attack surface is way shallower and smaller, and these people who have already migrated to a smart account fully and disabled their EOA probably are more aware of the dangers of signing, I don't know, arbitrary like hexadecimal bytes.
I think I follow what you're saying. Basically, right now, though, because it's an opcode, they have to have already deployed some delegation to their account, right? And that delegation needed to also support the ability to permanently migrate.
Yes.
I guess technically you could delegate immediately to a account that just immediately then calls in the same transaction the set code for your EOA. At the end of the day, I kind of said this in the chat, I feel like the attack surface, in my mind, if we assume that somebody could trick or convince or cause a user to blindly sign some piece of data, to me that's essentially game over for that user. 7702 certainly makes it the case, but even before 7702, like as batching standards continue to evolve, one signature could cause the majority of your funds to get drained. So I don't really see it as too much different than those situations. Ben?
Ben?
Sorry. I'd just like to highlight the conversation in the chat because there's 8050, which is trying to use a similar idea for deploying contracts, which would be solved with if there was a more general thing. And so the question is, should we change this IP, that IP, or create a new IP that's more general?
Sorry, what was the EAP?
Does it? 8050. 58, sorry.
Okay, 8058. My preference right now would probably be to keep this EAP as is. And if people prefer to do 80558, I haven't read this one fully yet,
Well,
but
that's not quite this idea because it uses access lists to give the address. But this a unified set code would work for this. So we can do that as a different EIP.
Yeah, I would say either
if
do
we
it as a
don't keep
different
this as a record.
EIP. Yeah, I would do it either as a different EIP or I would change 8058. Just depends what the authors feel there. I feel like for 7851, to me, it makes sense to kind of keep it as is, just to have the idea there. If for some reason we find in the future that people don't want to or we can't as easily do a generic set code from, then we have that to at least fall back to pretty easily.
Okay.
I know there's been some proposals for reusing the 7702 delegations for deploying code. Are there any EAPs that exist out there that already kind of do this that we should just be using? I think most of them reuse delegations, but what you're proposing is to actually set the code based on the. Is that right?
Yeah. And then you could use it for instance, like Uniswap v3 and so forth. They're constantly deploying liquidity pools, and rather than paying the full cost for the transaction, since you're essentially just copying code, you can go code hash from this address.
That makes sense. Okay, I'll take a look at the EAPs that exist and see if any of them do something like this, but I think this is slightly different, and so we can just introduce a different EAP. Thanks all for the feedback. Any other questions or comments? Yeah, send the emojis. All right, thanks.
Awesome. Thank you very much, Matt. And with that, that was the end of the agenda. Is there any other topic, anything anyone wanted to bring up on the call? Panos?
Yeah, maybe just one topic to mention. Last week, or maybe a week before, we decided to go with Marius's engine SSD changes instead of the proposal that I have submitted. So if you have implemented it, my proposal regarding the execution API changes, then maybe take a look into Marius's. It should be a small difference, and yeah, just that's it.
Ben, is that on the same point?
There was a concern on the number of deposits. Is that still in any particular block as the block size increases? Is that still a concern and something we need to address?
Yeah, I remember that concern. Do we have anyone with context on the call right now? Otherwise, I think we can also look into that async.
Yeah, I think that is more of a CL issue. So we could get around the issue in two different ways. We either increase the number of maximum deposits to like 2x, so that we're gonna be good for like 400 million gas, or alternatively, we add the IP 77. I don't know, the stable container EIP, and then we could just make that an optional field, and that would also get around the issue. But yeah, Putus can probably explain it a bit better.
So just to clarify myself on what you're saying. So there's one issue, which is the EL might, if we increase the gas limit, the EL might produce a block with enough deposits that the CL will not be able to handle, not because of compute, but because we would just like be over a hard limit, a hard code limit. We want to avoid that situation, and I think we agreed that we will try to keep progressive containers on the table. If we see that it's not getting in, then we're just going to increase the limit a lot. We can just change the number later on. But I also want to point out that Nico Flag, I'm not sure if, or Flag or whatever, I don't know how to pronounce your last name, Nico. They opened an EIP not long ago proposing a new model for having a new contract to send different requests for builder deposits, and that's another way of attacking the same problem. So perhaps you guys want to showcase your EIP.
Is there a concern that there will be too many signatures?
So there is an attack, which is a DOS, in which someone can send a lot of money with a lot of signatures, because the deposits are now allowed to be for 1 ETH, and create a lot of builders, and then the CL will not be able to handle it. And then we believe that this is not so much of an issue. On the one hand, for builders, it's not a good idea to produce such blocks. Also, we can handle a lot of signatures, and also that locks a lot of capital in the CL side that we can just fork off if it happens to be an issue.
Okay, so there isn't a problem with in terms of the amount of compute also, rather than just the container limit.
Well, so the one of the container is a critical problem, because if we do hit that limit, then we're gonna be in a situation in which we can't really process those blocks at all. But the compute one is also an issue. Clients will start lagging if this happens. We might see a lot of instability, but this is a very costly attack. We're talking several millions of dollars. and we can easily fork it without affecting a single transaction on mainnet.
Any other comments on this? Okay, then we still have 3 minutes to regain here. So then, unless there's anything else anyone wants to bring up, then we can end now. Okay, then thank you all, everyone, and see you all again in 2 weeks, either as a participant or coordinator. We will see. Awesome. Thanks, guys.
One more quick